Alrighty, I'm going to work out day 31. So as usual, I'd like it when you put the name of the program on the top and your name. And, why not put the date also? Okay, so looking at the instructions, it says ask the user for an integer using the try except structure we learned last week. Okay, so I remember this. If you don't remember, just look it up. Go get it out of the new quadratic formula program we did on Wednesday, or get it out of the Monday program last week. That'd be on the 19th of October. You do a while true, and you say try, and say n equals int input. Please enter an integer. All right, and then the next line is a break. Then you backspace one and say accept value error. And you know you did it right when it changes color. And this is where we put the error message. It needs to be an integer because this means they didn't enter an integer. Please try again. And then it automatically will repeat. Go back to the beginning. So this will make sure we get an integer. I'll show you what I mean. I'll run it. If I just hit enter, it says it needs to be an integer. Please try again. And if I type a bunch of text, it says it needs to be an integer. And if I type an integer 4, then it leaves. I like to put a space in front of my error messages so they sort of indent when you run them. I'll show you what I mean. See how the error, kind of calls out the error a little bit. Okay, so now we're back here, all the way to the left. The next thing says state if the number is odd or even. And so in my instructions, I told you how to figure that out. I said you do modulo 2. So if n modulo 2 equals 0. That means it's an even number, because if you can divide it by 2 and there's no remainder, then it's an even number. So you would say n is even right here. And then we'll do an else. You have to backspace, else, colon, print n is odd. Okay, so that says if the number is even or odd. The next thing is find the sum of all the integers from 1 to that number. So if you look at my instructions, under notes, I said you got to make a for loop and go from 1 up to the number. And you have to make a variable, like we could call it total, before the for loop starts. So I'm going to say total equals 0. All right, and then for x in range 1, comma. Now our number is n, but in a range call, you always have to do +1 if you want to include the number itself, because the range call always does 1 less than the second number. And here, I said it in my instructions, you say total equals total plus x. So what this does is if x was 4, if the number they entered was 4, then this range call would do this loop 4 times. X would be 1, then it would be 2, then it would be 3, then it would be 4. And each time through the loop, it adds the current number to the total. And so then when you're done with the loop, right here, you know what all the numbers add up to. Print the sum of all integers up to and including n is total. So I'll straighten out the line so you can see the whole thing. The sum of all integers up to and including n is total. So the word is has to be in quotes. This whole thing has to be in quotes. You can check if you're doing things right. You highlight a quote and then it shows you the other quotes. You need to have pairs of quotes. Why don't we run it too? I also told you that if you entered 4, the sum of all the numbers up to including 4 is 10. I said that in my instructions because 1 plus 2 plus 3 plus 4 is equal to 10. Okay, so we've done the first 3 bullets. There's 3 more bullets to go. Next, it says find all the factors of the number. Store them in a list. Then print the list. For example, the factors of 6 are 1, 2, 3, and 6. And the factors of 7 are 1 and 7. So factors are all the ways you can multiply numbers together to get a bigger number. So I tell you how to do that. I mention it in the instructions. I said you should make a list variable that's empty. We'll call it factors. And then we're going to do a for loop from 1 up to the number. So let's do this. Factors equals an empty list. That's empty square brackets. And now we're going to say for x in range 1, comma, n plus 1 again. We want to go all the way up to the number. And now we're going to check. Is n divisible evenly by the current number? So if n modulo x equals 0, that means, like, so let's take it when it's 1. Let's say we were doing 4. If 4 divided by 1 has no remainder, then that means 1 is a factor of 4. And it is. So we would say factors append x. And then the loop would go through and x would be 2. 4 divided by 2 also has no remainder. So 2 would get added to this. So right now, if we were doing this example of 4, we would have 1 and 2 in the factors list. Now, when 3 comes through, 4 divided by 3 has a remainder. So 3 wouldn't get added to the list. And then finally, when 4 comes through, 4 divided by 4 is perfect, right? So 4 would get added to the list. So at the end of this, we would have 3 numbers in here. I'll just show you factors, and we'll run it with the number 4 so you can see. Please enter an integer. I'm going to enter 4, and the sum of all integers up to and including 4 is 10, and the factors of 4 are 1, 2, and 4. So I think I'd like to add a little thing. The factors of n are, and we'll just run it again. I just like to say what's going on. Okay, not too bad. Then report if the number is prime or not. And the number is prime if it can only be divided by itself and the number 1. So 4 is not prime, right? Because it has a 1, 2, and a 4. But I'll show you a prime number. We can put 3 in. And 3 has only 2 factors, 1 and 3. So bottom line is, and I tell you this in the instructions, you can tell if a number is prime by checking how long this list of factors is. If there's just 2 things in the factors list, then it's prime. And if there's more than 2, it's not prime. So if len factors, that means if the length of the factors list is equal to 2, then we say n is prime. And then otherwise we say nah. N is not prime. All right, let's see how that goes. So let's try 19. I didn't know, but 19 is odd. I knew that. But the sum of all integers up to including 19 is 190. The factors of 19 are 1 and 19 is prime. And let's try, I've got a really fun number, 240. It's even. It's got a really big number if you add up all the numbers. And look at all the factors. 1, 2, 3, 4, 5, 6, 8, 10. And 240 is not prime, right? Because it can be multiplied by all kinds of things. Okay, and then the very last thing I asked you to do is ask if the user wants to run again. So I want you to learn this skill. At this point, the way to do that is to, at the very top, above everything, add another while true, and then select your whole program, the whole rest of the program, and just hit tab. And what that does is it brings the whole rest of the program indented inside of that top while true. Okay, and then right here at the end, hit enter maybe twice, backspace once. So we got to be lined up with everything over here. We're not on the far left. We're 1 level indented because we're inside of this while true. And we have to say r equals input, run again, yn. You don't have to use the variable r, but that's just what I do. If r is equal to no, and I'm going to make sure, well, anyway, that's fine. If it's equal to no, we're going to print a goodbye message. Goodbye. And then we're going to break. Otherwise, it's just going to repeat again. So I think for the repeat, I'm going to print a blank line, just not indented there. So let's see what happens. Enter an integer. So I'm going to do the full test. I'm going to hit enter like I didn't enter a number. I'm going to enter 4.5. That's not an integer. I'm going to enter text. That's not an integer. Okay, so now I'm going to enter an integer. I'm going to say 24. 24 is even. The sum of all integers up to including 24 is 300. The factors are blah, blah, blah. 24 is not prime. Run again. I'm going to say yes. Please enter an integer. This time I'm going to do 137. And I just happen to know that's a prime number. And the factors of 137 are 1 and 137. And 137 is prime. Run again. And I'm going to say no. And we're done. So I can almost show the whole program here, but not quite. Here's the start of it, all the way up to the prime part, and then the very end right there. Okay, good luck.